We all know the first rule of the universe. It is the golden rule of astrophysics, the one that keeps us up at night and fuels our worst nightmares. Nothing escapes a black hole, not a planet, not a star, and certainly not light itself. Once you cross that invisible line in the sand, the event horizon, you are gone. You are deleted from the reality of this universe, crushed into a point of infinite density where space and time no longer make sense. For over 100 years, this has been the end of the story. A black hole is a cosmic trash can, a one-way door to oblivion. It is the period at the end of the sentence of existence. But what if we've been reading the story backwards? What if the math that predicted these monsters also predicted their opposite? According to the very same equations that Einstein used to describe gravity, there is a twin hiding in the dark, a cosmic mirror image. If a black hole is a place where you can never leave, there must be a place where you can never enter. A place that spits out light and matter, refusing to let anything inside. An object that burns with the intensity of a billion stars, creating galaxies instead of destroying them. Physicists call them white holes. And here is the scary part. They aren't just science fiction, they are mathematically real. They are seemingly unavoidable consequences of the laws of physics. And some scientists believe that you, me, and everything we see might actually be living inside the exhaust of one right now. Today we are going to hunt for the ghost of the universe. We are going to find out if the black hole actually has an exit. To understand how something so impossible could exist, we have to look at the map of the universe itself, general relativity. When Carl Schwarzschild first solved Einstein's equations in the trenches of World War I, he wasn't looking for monsters. He was just doing the math. But inside the numbers, he found a catastrophe. He found a point where gravity became infinite. For decades, people thought it was just a glitch, a mistake in the algebra. But then we found them. We took pictures of them. Black holes were real. The math was right. But here's the thing about physics that is hard to wrap your head around. Math doesn't care about time. In the eyes of a pure equation, time is just a variable. It can move forward or it can move backward. The laws of physics are what we call time symmetric. If you videotaped a planet orbiting a star and played it in reverse, the gravity still works. The orbit still makes sense. If you videotaped two billiard balls crashing into each other and played it backwards, the transfer of energy still makes perfect sense. So the question becomes, what happens if you play the life of a black hole in reverse? If you take the video of a star collapsing into nothingness and hit rewind, you see something terrifying. Instead of an event horizon that nothing can escape, you see an event horizon that nothing can enter. Instead of matter falling in and being crushed into a singularity, you see matter exploding out from a singularity. You see an object that generates matter and light spontaneously, throwing it out into the universe, but refuses to let anything back in. If you tried to fly a spaceship into a white hole, you would be fighting against a stream of space-time itself. It would be like trying to swim up a waterfall. No matter how much energy you used, the space itself would be rushing out faster than you could move in. You would never reach the center. It is the ultimate shield. This object is perfectly legal, according to Einstein. The math says it should exist. So, where are they? If the universe loves symmetry, if for every electron there is a positron, and for every North Pole there is a South Pole, then where is the opposite of the black hole? There is a problem, of course, a big one. It's called the second law of thermodynamics. Entropy. The universe generally moves from order to disorder. You can break an egg, but you can't unbreak it. You can burn a log into ash, but you can't turn ash back into a log. A black hole makes sense because it takes ordered things, stars, planets, light, and crushes them into disorder. It increases the entropy of the universe. A white hole does the opposite. It takes a singularity, pure chaos, and spits out organized matter. It's like watching an omelet turn back into a raw egg. It feels wrong. It feels like it violates the flow of time. For a long time, physicists dismissed white holes as impossible because of this. They said, sure, the math works on paper, but the universe would never allow it. But then we started looking closer at the black holes themselves. And we realize that without white holes, physics breaks anyway. We know black holes slowly die. Stephen Hawking taught us that they leak radiation. They get smaller and smaller over billions of years. But what happens when they get tiny? When a black hole shrinks down to the size of a proton, the laws of gravity break down. Quantum mechanics takes over. This is the greatest crisis in modern physics, the information paradox. Quantum mechanics says that information can never be destroyed. If you burn a book, the information in that book isn't gone. It's just scrambled into ash and smoke. If you had a supercomputer, you could theoretically reconstruct the book. But a black hole? It deletes the book. If a black hole evaporates completely, where did the information go? If it disappears, then all of physics is a lie. This is where the white hole returns to save the day. Some physicists, like Carlo Rovelli, have proposed a wild theory called quantum bounce. Imagine a ball falling from the sky. As it hits the ground, it compresses, stops for a millisecond, and then bounces back up. Rovelli suggests that a black hole is doing the exact same thing. It is a star collapsing under gravity, squeezing down, down, down until it hits the bottom of reality. It hits the limit of how small space can get, a unit called the Planck length, and then it bounces. Space-time snaps back. The black hole turns inside out. It becomes a white hole. Now you might ask, if black holes turn into white holes, why haven't we seen one yet? The answer is time dilation. Gravity slows down time. Deep inside the black hole, the bounce happens instantly. It takes a fraction of a second. But for us, watching from the outside, the gravity is so strong that the second is stretched out into billions of years. This implies something mind-bending. Every black hole we see in the sky right now, Sagittarius 8 in the center of our galaxy, the massive monster in M87, they are all stars that are mid-bounce. We are just watching them in extreme slow motion. And when the bounce finally finishes, when the black hole dies, it will disappear and a white hole will appear in its place, spitting out everything the black hole ate over its entire lifetime. The black hole is the archive, and the white hole is the playback. Nothing is lost. The universe preserves its memory. But there is an even bigger, crazier possibility. One that changes not just our understanding of stars, but our understanding of reality itself. Think about the Big Bang. 13.8 billion years ago, a singularity appeared out of nowhere. It was infinitely dense, infinitely hot, and contained all the matter in the universe. And suddenly it expanded. It spit out matter, energy, time, and space. It didn't let anything in because there was no outside to come from. It only pushed things out. Does that sound familiar? Many physicists have noted that the Big Bang looks suspiciously, mathematically identical to a white hole. If you were standing inside a massive white hole, you would see things expanding away from you. You would see a universe being born. This leads to a theory called cosmological natural selection. It suggests that our universe is not unique. It suggests that maybe our universe is just the exhaust of a massive black hole in another dimension. Imagine a parent universe. In that universe, a massive star collapses. It forms a black hole. It tears a hole in the fabric of that universe's space-time. But that hole has to lead somewhere. Maybe it leads to a bubble on the other side, a white hole. And that white hole spits out all the matter from the collapsed star, creating a brand new Big Bang, a brand new universe. If this is true, then we are living inside the explosion. The reason we can't find white holes in our sky is because we are inside one. The expansion of the universe, the dark energy pushing galaxies apart. Maybe that is just the force of the white hole spewing us out into existence. It also means that every black hole in our universe might be creating a baby universe inside of it. A trillion new realities branching off from our own, hidden behind the event horizons. We haven't found a definitive white hole yet in our sky. In 2006, astronomers thought they found one with a gamma ray burst that lasted 102 seconds, an event that shouldn't have been possible. It appeared, screamed into the void, and vanished without a trace. We still don't know for sure what it was, but the hunt continues because if white holes are real, they solve the biggest mysteries we have. They tell us that death isn't the end of a star, but a transformation. They tell us that information is immortal, and they tell us that our Big Bang might not be the beginning of everything, but just one breath in an infinite cosmic lung. In a universe where invisible matter makes up 95% of reality, where time bends, and where dead stars can rip the fabric of space, is an exit door really that crazy?